Next problem. Find the Fourier series of f of x equal to x square in the interval minus L to L. In the interval minus L to L. Now, f of x equal to x square is an even function. In minus L to L. Arbitrary interval minus L to L. Even function in minus L to L. Therefore, obviously, Bn equal to, whenever even function, Bn equal to 0 for all n. Therefore, Fourier series is f of x equal to, a naught by 2. Now, what is this one? Arbitrary interval in terms of L. N equal to 1 to infinity, an cosine n pi x by L. Cosine n pi x by L. Okay. And where a naught equal to 1 over L minus L to L, f of x dx. That is equal to 2 by L. Since it is even function, I can write 2 by L. This is x square dx. So 2 by L x square x cube by 3, 0 to L. So final answer 2L square L cube. L gets cancelled. A naught value is 2L square by 3. 2L square by 3. Similarly, an value 1 by L minus L to L, f of x into cos n pi x by L. Cos n pi x by L dx. So this is 2 by L, 0 to L, since it is even function. Cosine is also even function. One can write like this, n pi x by L dx. Now, this is by parts formula. By parts formula, an equal to 2 by L. Now, x square is derivative part and this cosine is integrating part. So first, derivative part as it is. Cosine integration is sine n pi x by L. And what is x quotient? N pi by L. So that is in denominator. Minus. Now x square derivative is what? 2x. X square derivative is what? 2x. Again, sine integration is what? Cos n pi x by L by n pi by L into n pi by L. N square pi square by L square. N square pi square by L square. Next one. Plus minus plus. 2x derivative is what? 2. Again, cosine integration is what? Sine n pi x by L by n pi by L into n square pi square by L square. That is n cube pi cube by L cube. This is totally between 0 to L. Okay, but repeated by parts formula. Derivative part derivative, integrating part integration. Okay, that is equal to 2 by L. Now, substitution of limits. First, upper limit L. This L, if I substitute here in place of x, L gets cancelled, sine n pi 0. First term is 0. This minus into minus plus in place of x L. So this is 2L and I can write this one L square by n square pi square, and if I put L here, this becomes cos n pi. Second term is over. Third term in place of x, if I put L sin n pi, that is 0. So this is upper limit value. Minus, coming to lower limit 0, x plus in place of x. So 0, here also x is there, therefore 0. Here also sine is there, sine 0, 0. So everything 0. So this is closed. Okay. Now this equal to, this is 2 by L. What is this one? 2 by L, 2L cube by n square pi square cos n pi. Cos n pi is nothing but minus 1 whole power n. Therefore, what is an value? 4L square by n square pi square into minus 1 whole power n. Okay. Therefore, Fourier series is f of x equal to a naught. What is a naught? A naught is 2L square by 3. 2L square by 3 into 2 plus summation n equal to 1 to infinity. This is 4 into minus 1 whole power n, L square by n square pi square cosine nx. This is the Fourier series in the arbitrary interval minus L to L. One model problem. Okay. And the next one,
cos n pi x by L.
yeah, cos n pi x by L. Cos n pi x by L. And let me tell you one more problem on arbitrary interval. Arbitrary interval. Yeah, take this. Find the Fourier series of f of x equal to x in the interval 0 less than or equal to x less than or equal to 3, and 6 minus x in the intervals 3 less than or equal to x less than or equal to 6. 3 less than or equal to x less than or equal to 6. Solution. Now, what is the interval here? The interval is what? Complete interval. Here, the interval is 0 to 6. Now, this is not pi in terms of pi. So, I have to compare this interval with 0 to 2L. 0 to 2L. That means 2L equal to 6. And what is the L value? 3. L value 3. This is the first observation. Next one. And since this is not minus L to L, no need to check even and odd function. So directly Fourier series is f of x equal to a naught by 2 plus summation an cosine n pi x by L plus summation bn sine n pi x by L. This is equation 1. N is 1 to infinity, 1 to infinity. Now 1 by 1 quotient. First one, what is a naught formula? 1 by L. What is interval? 0 to 2L interval. So 0 to 2L f of x dx. And what is the L value? 3. And this becomes 0 to 6 f of x dx. 2L is 6. Now split into two parts. This is 1 by 3. Since 0 to 6 interval is split into two parts, 0 to 3. In 0 to 3, what is f of x? X. And in 3 to 6, what is f of x? 6 minus x dx. 6 minus x dx. Next integration. 1 by 3. This is x square by 2 between 0 to 3. This is 6x minus x square by 2 between 3 to 6. That is equal to 1 by 3. First, anyway, lower limit 0, upper limit 9 by 2. Plus coming to here, the upper limit 36 minus 36 by 2. 18. Upper limit minus lower limit 3. 18 minus 9 by 2. 18 minus 9 by 2. So 1 by 3. This is 9 by 2 plus 18. And this is minus 18 plus 9 by 2. So these two cancel. 9 by 2, 9 by 2. This is 9. 9 value, 9 by 3. This is value 3. So A naught value is what? 3. Next one. An equal to what? 1 over L, 0 to 2L, f of x into cos n pi x by L dx. Now this is 1 by 3, integral 0 to 6, f of x cos n pi x by what? L value 3. L value 3. So again split into two parts. This is 1 by 3. First 0 to 3, the function is x, cos n pi x by 3, cos n pi x by 3 dx plus integral 3 to 6. This is what function? 6 minus x into cos n pi x by 3 dx. That is equal to 1 by 3. Now first one integration by parts formula, derivative part and integrating part. X as it is, sine integration is, cosine integration is n pi x by 3 by x quotient is n pi by 3 minus x derivative 1, and again sine integration minus cosine n pi by 3 by n square pi square by 9. This entire between what limits? 0 to 3. 0 to 3. Now coming to second one, plus I'm starting with here 6 minus x. This is sine n pi x by 3 by n pi by 3. Minus 6 minus x derivative is what? Minus 1, and minus cosine n pi x by 3 by n pi by 3. This entire is 3 to 6. 3 to 6.
Sir, n square pi square by
Sir,
9.
n square pi square.
Yeah, n square pi square by 9. Okay, and this whole bracket closed. Now one by one, substitution. This is equal to 1 by 3. First upper limit 3. This 3 is substituted. 3 is substituted here. 3 gets cancelled. Sin n pi value 0. This is upper limit. This minus into minus plus. This is 9 by n square pi square. 9 by n square pi square cos n pi. 3 gets cancelled. Cos n pi. Okay, this is upper limit. Minus coming to lower limit 0. In place of x 0 means first term 0. And cos 0 value 1. So this is minus into minus plus n square pi square by 9. N square pi square by 9. First term limit substitution is over. Coming to second one, upper limit.
Sir, 9 by n square pi square.
Yeah. 9 by n square pi square. This is 9 by n square pi square. Now coming to second one, this 6, this upper limit first one 0. And here, if I substitute 6 here, 3 2s are. So this minus will be there. 9 by n square pi square cosine, what is this? 2n pi. Cosine 2n pi. This is upper limit. Minus, coming to lower limit, 3. 3 gets cancelled. So sin n pi 0. And this is minus 3 gets cancelled. 9 by n square pi square cos n pi will be there. This whole bracket closed. Whole bracket closed. Okay. Now, this is equal to 1 by 3. First one is 9 by n square pi square cos n pi. Next, minus 9 by n square pi square. And cos 2n pi is plus 1. Okay. So this is minus 9 by n square pi square. And this is minus into minus plus 9 by n square pi square cos n pi. Any corrections? Once again, 9 by this, right? Minus 9, right? Minus 9, right? And plus 9, right? So totally 9 by 3 n square pi square. This is common. Okay. And these two are same. These two are same. Done? So into 2 you will get. So 18. 18 is common, and clubbing these two, what I will get? Cos n pi will be there, minus here 1 will be there. Is it correct? This is 9 plus 9, 18. This is also 18, right? So this is equal to 6 by n square pi square minus 1 whole power n minus 1. This is an value. Now this is equal to, this is 0 if n is even. When n is odd, minus 12 by n square pi square if n is odd. If n is odd, an is over. Now coming to bn. Now see, all the quotients are there here in this problem. 0 to 2l f of x into sine n pi x by l dx. This is equal to 1 by 3, 0 to 6 f of x sine n pi x by 3 dx. N pi x by 3 dx. Now split into two parts because the function is defined in two intervals. This is x into sine n pi x by 3 plus integral 3 to 6. What is this function? 6 minus x, right? Sine n pi x by 3 dx. Now again by parts formula. This is equal to 1 by 3. This x sine integration n pi x by 3 by n pi by 3. This is in bracket because minus is there. Minus x derivative 1. And again cosine integration sine by n pi by 3, n pi by 3. This is n square. This is between what limits? 0 to 3. 0 to 3. Coming to second one, plus 6 minus x minus cosine n pi x by 3 by n pi by 3 minus 6 minus x derivative minus 1, and again cosine x derivative sine n square pi square by 9. And this is what between limits 3 to 6. This entire closed. Now substitution of limits. This is 1 by 3. First upper limit 3. 3, if I put here 3, 3 gets cancelled, and here also 3 in place of x. So this becomes minus 9 by n pi cos n pi. First term. And when I put x equal 3, 3 gets cancelled, sin n pi value 0. This upper limit is over. Coming to lower limit 0, x 0 and sin 0 0. So totally 0. This part is over. Coming to in the second part, this upper limit in the second this bracket, upper limit 6 minus 6 0, minus 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 minus. If I put 6 here, you will get sin 2n pi. What is sin n pi? Always 0. So upper limit 0. Coming to lower limit 3. 3 if I put here, this is 3. 3 means this becomes 9 by n pi. 3 gets cancelled, cos n pi, and minus will be there. Minus will be there, right? Next one, minus minus minus. Anyway, 3 gets cancelled. This part 0. All the limits are substituted. Upper limit minus lower limit. Now only these two terms are there. I think this is minus 9 by n pi and this is plus 9 by n pi, right? These two gets cancelled. That means bn equal to 0. Bn equal to 0. Therefore, Fourier series is f of x equal to, what is a0 value? A0 value 3. A0 value 3 by 2 plus summation n is odd is given, and or one can write n equal to 1, 3, 5 and so on up to infinity. And what is an value? Minus 12 by n square pi square. Minus 12 by n square pi square cos n pi x by 3. This is the answer. You can simplify this is further. Okay. Or one can write like this. F of x equal to 3 by 2 plus, minus 3 by 2 minus constant outside, summation n equal to 1, 3, 5 and so on infinity. What is this? 1 by n square into cos n pi x by 3. This is the Fourier series. Okay, this is Fourier series in an arbitrary interval. Fourier series in an arbitrary interval. You take some assignment problems. First one, same question is same. Find Fourier series. Find Fourier series. F of x equal to pi x in interval 0 to 1. 0, you take and x equal to 1. That means no need. Instead of this, you take this problem. Why should I confuse you? This is f of x equal to pi minus x by 2 in interval 0 less than or equal to x less than or equal to 2. Next one, f of t in place of x, t is there. That's it. That is the change. 1 minus t square minus 1 less than or equal to t less than or equal to 1. And third one, f of x equal to 2x minus x square in 0 to 2. In 0 to 2. That's enough. Okay. These are the 3 assignment problems in arbitrary interval, or one can try this. Yeah, fourth one. A sinusoidal voltage capital E sin omega t is passed through a half wave rectifier which clips the which clips the negative portion of the wave, negative portion of the wave develop the resulting periodic function, develop the resulting periodic function u of t, instead of f of x, u of t is given, u of t equal to 0 in the interval minus t by 2 less than small t less than 0, and is equal to e sine omega t, in the interval 0 less than t less than capital T by 2, in a Fourier series, Okay, this is what off wave rectifier problem. Okay, if you draw the figure of this one, just imagine. Okay, this is t axis and this is the function u of t. And what are the limits? The function is defined in minus t by 2 to plus t by 2. These are the t values. In minus t by 2 to 0, what is the function value? 0. So this one, function value 0. And in 0 to t by 2, what is the function? Sine function, sine omega t. You know, sine omega t. And what is it is given? Negative side, which clips the negative portion of the wave. So this one, not like this. This is negative portion like this. This is 0. Okay, this is off wave rectifier. And clearly in minus pi by 2, minus t by 2 to t by 2, what is the length? T. What is the length? T, like minus L to L problem. Minus L to L problem. L value is here what? This is minus L to L problem. Minus L to L problem. This is minus t by 2 to plus t by 2. Okay, so what is the L value? Don't confuse. L value t by 2. L value t by 2. This is the hint. You solve this problem. Okay, this is about in Fourier series in an orbital interval. The next topic is off-range Fourier series. Off-range Fourier series. Off-range Fourier series. What is mean off-range Fourier? Till now we have studied, okay, let me explain. We have Fourier series of f of x. In what interval actually? In the interval, let me write general, in general 0 to 2L, where L may be pi. L, if L equal to pi, our first case 0 to 2 pi case. And so generalization is always 0 to 2L. We have Fourier series of f of x in 0 to 2L of period 2L, 0 to 2L, or one can write minus L to L. This is also of period 2L, Then this is here full period. The length of the full period is 2L. The full period is 2L. Now, so full range Fourier series is defined over the period 2L only. Now clearly it is given, what is this? Off range. Off range means what? 0 to L. The function is having period L only. Okay, in many practical problems, in many practical situations, we require Fourier series of f of x in the interval. What is the interval? 0 to L only. This is important. In the interval what? 0 to L only, which is exactly half of the period, half of the interval 0 to L. Okay. And what is practical situation means here? See, for example, just example. Actually, you will not understand this, but try to understand this. There is a string of length L only, so this is x equal to 0 and this is x equal to L. This is a string of length L which is fixed at or fastened at two endpoints, x equal to 0 and x equal to L. If I make a vibration in the string, that means if I make a vibration in the string, then it produce one equation. What is that equation? Dou y by dou t, or dou square y by dou t square equal to c square into dou square y by dou x square, which is called wave equation. Dou square y by dou t square equal to c square into dou square y by dou x square, which is, this is one dimensional wave equation. Why one dimensional? Means the oscillation is in one direction only. Okay, now this is one dimensional wave equation. What are the conditions? With the conditions, what this is here, y is called displacement. Here y is called displacement in the string. And t means time, and x means the distance, the length. So this y depends on what? Y depends on x as well as t. That is why we are getting partial differential equation. Now what are the conditions here? First one, at x equal to 0, that means 0 comma t, there is no vibration in the string, that means no displacement. Same logic at the end point L also, there is no displacement. These are the standard conditions for wave equation. Y of 0t, y of LT 0. Another condition is initial displacement. Initial means at a time t equal to 0. The initial displacement, it may be 0, may not be 0. Maybe 0 or may not be 0. Let me consider some function of x. And initial velocity. Velocity means what? For displacement, the derivative. And initial means what? Time t equal to 0. So dou y by dou t represents what? Initial velocity, some function g of x. This complete is called one-dimensional wave equation. In solving such type of equation, we require half-range Fourier series. This is the practical situation. Same logic, one-dimensional heat equation. What is the heat equation? Dou u by dou t equal to alpha square into dou square u by dou x square. What is here? There is a rod of length L. See, this is length L on. Due to this length only, here also what is the length of the string? L only. That means I have to find the Fourier series in what interval? 0 to L only. That is why half range is required. Same logic here also, half range is required in solving heat equation. Okay, that is the purpose of learning half range Fourier series. Then how to find? See, logic is what? I know the Fourier series formula only in the interval either 0 to 2L or minus L to L. 0 to 2L or minus L to L. Okay, there is no other chance. In 0 to L, I cannot write my Fourier series. Okay, that was first thing. Case 1. Half range cosine series. Okay, this is the first one, half range cosine series. Consider a periodic function f of x in what interval? In the interval 0 to L only. 0 to L with period L. Periodic function f of x in the interval 0 to L. Okay. Now to get, just I'm giving the explanation, to get Fourier series of f of x in 0 to L. Now this is important. Extend the function f of x in interval minus L to 0. In the interval minus L to 0, extend the function f of x in the interval minus L to 0 as an even function. So that the function f of x is now defined. So that the function f of x is now defined in the interval defined in the interval minus L to L, which is of period 2L, which is of period 2L. That means what? See the concept. Consider a periodic function f of x in the interval 0 to L. I required Fourier series, but Fourier series is available in 0 to 2L or minus L to L, which is of period 2L. So to get that point, now let me draw the figure. For example, f of x equal to x function in 0 to L. In 0 to L. What is this function 0? This is x and this is f of x. Y, this is nothing but y equal to x, right? This is y equal to f of x. So y equal to x in 0 to L, this is my L. So y equal to x in 0 to L, what is this? This is my function. In 0 to L, this is a straight line, right? But I need Fourier series expansion. So for that, what we are doing, expand the function in the interval minus L to 0. In the interval minus L to 0 as an even function. This is important. As an even function. Even functions are always symmetric about y-axis. Symmetric about y-axis. As an even function in minus L to 0, its shape also straight line. Same function y equal to x is extended in the interval minus L to 0 as an even. That means this is symmetry. This is symmetry. This is symmetric line. So its image behaves here as an even function, and clearly even function is symmetric about y-axis. Symmetric about y-axis. That is why its shape is here like this. Now what is my complete interval? Minus L to plus L. And what is the problem now? Minus L to plus L. Function is f of x equal to x. Function is f of x equal to x. I can expand. I can find Fourier series. Since we are expanding as even function, since we are expanding the function as even function, let me write. Since we are expanding f of x as even function over what is my complete interval now? Minus L to L. Definitely what is Bn equal to 0? Bn equal to 0. Okay. Therefore, Bn equal to 0. Therefore, Fourier series of f of x contains only a0 and an. A0 and an. That is only cosine terms. Only cosine terms. Only cosine terms. Therefore, the above series, the series or the Fourier series of f of x in 0 to L is called half-range cosine series. Half-range cosine series. Half-range cosine series. Now, you may get one doubt. Sir, this is f of x equal to x. If I expand this in minus L to L, f of x equal to x is odd function na? Now, that is the beauty of this half-range. What is this? Forget about the behavior of the function in minus L to 0. Minus L to 0, I don't require the behavior of the series. Okay. Just to get the Fourier series expansion, I am expanding. That means to get the period as 2L, I am expanding the function in minus L to 0 as an even function. That means for this problem, now just hint. What is this? F of x equal to x in 0 to L, we have both half-range cosine series and half-range sine series. Half-range sine series. That is the beauty of this half-range series. For any function which is periodic in 0 to L, I can find half-range cosine as well as half-range sine. And in half-range cosine series, we are expanding the function as even function. We are expanding the function as even function. Remember that point. Okay. Therefore, what is the series becomes? Therefore, half range cosine series of f of x in 0 to L is what? F of x equal to a naught by 2 plus summation an cos n pi x by L. There is no change in the formula. There is no change in the formula. But see the quotients, what quotients becomes? What is a naught? What is a naught value? Actually, now what is interval? Minus L to L now. So a naught equal to 1 by L minus L to L. We are extending the function to get the Fourier series. So this is becomes 2 by L 0 to L f of x dx. You remember this directly. 2 by L. Okay. Similarly, what is an value? 1 over L minus L to L f of x dx, and this is 2 by L 0 to L f of x into cosine n pi x by L dx. N pi x by L dx. This is half range cosine series. Clearly, shortly, I'm telling you, if f of x Fourier series is required in the interval 0 to L, it is not possible directly. So, to get the period as 2L, we are extending the function f of x in minus L to 0 as an even function. Remember, even function, which is symmetric about y-axis. Okay, then our interval becomes minus L to L completely, which is of period 2L. Then it is possible to expand Fourier series of f of x. Even function means bn 0. So remaining quotients are a0 and an. So Fourier series becomes this and this. And one can think, what is the change when interval is minus L to L and 0 to L? For example, see, half range. Okay, let me Fourier series. Just explanation. Remark. Say Fourier series of f of x equal to some x in the interval 0 less than x less than 2. This is Fourier series. This is Fourier series. So what is this interval is compared with what? 2L, right? 0 comma 2 is the interval. This is compared with what? 0 to 2L. That means what is 2L equal to 2 and what is L value? 1. L value 1. Keep this one in mind. If half range cosine series of f of x equal to x in the same interval 0 less than x less than 2. Here, since it is half range, we compare the interval with 0 to L. That means here L value 2. That is the change. Here L value 2. This is the change. Remember this. When the question is half range, compare the interval with 0 to L. When it is full range, compare the interval with 0 to 2L. Okay. Then entire problem is different. Formula may be same, but L value differs. This is half range cosine series. Next, half range sine series. Half range sine series. What is the idea here? Now, if we require Fourier series of f of x in the interval 0 to L, then to get the length of the interval, as 2L, extend the function f of x as an odd function, I will write here. Odd function means symmetric about origin. Odd functions always symmetric about origin. As an odd function in what interval? Minus L to 0, so that the interval becomes minus L to L, which is of length 2L. That means what here? Just I'm giving same explanation. F of x equal to x in the interval 0 less than x less than L. This is 0, this is L. This is straight line. Okay. Okay, now since it is, if I expand in minus L to 0 as an odd function, as an odd function which is symmetric about origin, means its shape in this interval will be like this. Like this. So in minus L to L, this is complete function. Minus L to L, complete function. Now, since f of x is now an odd function, f of x is now an odd function in minus L to L, we have a0 and an, both are zeros. Both are zeros. Therefore, Fourier series of f of x is f of x equal to summation bn sine n pi x by L, n is from 1 to infinity, the C star, which is called, which contains only sine terms, and is called off range sine series. Okay, where what is Bn formula? Same logic, 1 by L minus L to L f of x sine n pi x by L dx. That means this is odd function, so product is even. 2 by L, 0 to L f of x sine n pi x by L dx. This is Bn. So this is off range sine series, and this one, previous one, this one off range cosine series, and the formula is same like in minus L to L interval, even and odd function. Only the difference is in L value. Any doubts? Check out. Concept is this: off range cosine series and off range sine series.
So,
Yeah.
why is A0 0 in half range sine series, whereas in half range cosine series, A0 is considered in Fourier series?
See, see, what is this? In off range sine series, we are what is the function?
Odd.
What is the A0 formula? 1 over L minus L to L f of x. Odd function, na? What is minus L to L integration minus L to L odd function?
0, sir.
0. That is why 0.
Okay, sir. Thank you.
Okay.
Sir. Yes, sir.
Any more? Concept is clear, na? In the examination or a problem is given, how the problem is given? Find the off range cosine series of f of x equal to x. F of x equal to x in interval 0, 2, like that. Okay. That you write the formula, off range cosine series formula, and 0, 2 interval is compared with what? 0, L, not 2L. Keep this one in mind. Same logic is applicable for sine series also. Off range sine series also. Clear? Concept is clear now? Shall I start the problem? Okay. First problem. Let me take, yeah. Fine. Already I did this problem, no? Yeah, this is better. Obtain a off range cosine series. Time will not permit for this. Let me take another one. In exercise, they written maybe there. Yeah, x square off range sine series. Let me take off range sine series of x cos x. Off range, let me consider sine series. Off range sine series of f of x equal to x into cosine x. X into cosine x in 0 to pi. In 0 to pi. Okay. Solution. Here, what is interval? Here, What I required, off range. Off range means what? 0 to L is nothing but 0 to pi. This gives L value pi. First observation. Next, you write off range cosine series. Off range sine series. Off range sine series of f of x is, off range sine series of f of x is f of x equal to summation bn sine n pi x by L. General formula you have to write sine n pi x by L. Okay, this implies f of x equal to summation bn L value pi. L value pi. If I substitute, I will get this sigma bn sine n pi x by L. Where what is bn formula? One can write directly 2 by L, 0 to L, f of x sine n pi x by L dx. Sine n pi x by L dx. That is equal to L value is pi. So 2 by pi, 0 to pi, and what is this function? X cosine x into sine L value pi. So this becomes nx. This becomes nx. Okay. Now take 2 inside. 2 inside. 1 by pi integral 0 to pi x into 2. One can write 2 sine nx into cos x dx. 2 sine a cos b formula. 2 sine a cos b formula. So 1 by pi integral 0 to pi x into sine a plus b. Sine a plus b plus sine a minus b dx. A value nx, b value x. Okay. Now by parts formula, 1 by pi, x is derivative part and this entire bracket is integrating part. X as it is, first this one integration minus cos n plus 1 x by n plus 1 minus cos n minus 1 x by n minus 1. Right? Minus x derivative 1, again integration of this minus sine n plus 1 x by n plus 1 whole square. Right? Next one, and minus sine n minus 1 x by n minus 1 whole square. Right? This entirely between what limits? 0 to pi. And this integration is valid for what? N not equal to 1, because n minus 1 term is there. Okay. Now substitution of limits. 1 by pi. First upper limit pi here in the first expression. This is pi minus cos, take pi inside, pi plus n pi by n plus 1 minus cos pi minus n pi. You can take minus common, cos of minus theta, cos theta, so it doesn't matter. Next, coming to second one, this minus pi value. So sin n pi 0. So 0, 0. This is upper limit. Minus, coming to lower limit 0. 0, 0 into something 0 and sin 0, 0. So completely 0. Right? And next, this is equal to 1 by pi. This is pi into, okay, minus common, minus pi, cos pi plus theta, cos pi plus theta, minus cos theta. So minus cos n pi by n plus 1, cos pi minus theta, minus cos theta. So this becomes plus cos n pi by n minus 1. This is in brackets.
Sir, minus all taken common.
Where?
In above, sir. Minus there. No.
Wait. Cos pi plus theta minus cos theta. This minus plus. Done? And here also minus this plus, correct?
Yes, sir.
And this is also plus, right? Now
Yes.
is it okay? Right?
Yes, sir.
Now pi gets cancelled. Pi gets cancelled. Cos n pi is common. Cos n pi is common. 1 by n plus 1 plus 1 by n minus 1. So this is the value of bn minus 1 whole power n, and n minus 1 plus n plus 1 by n square minus 1. This is minus 1 whole power n 2n by n square minus 1. This is bn for for n not equal to 1. N not equal to 1. Now, for n equal to 1. For n equal to 1, what is b1? 1 by L, 2 by L, 0 to L, f of x into sine n pi x by L, n value 1. So this is 2 by pi, 0 to pi. And what is this f of x? X into cosine x, and this is L value pi. L value pi gets cancelled, sine x dx. So take 2 inside. So this is 1 by pi integral 0 to pi. What is this? X into sine 2x, 2 sine x cos x, right? This is it. Okay. Let me write here. This is 1 by pi parts formula, minus cos 2x by 2 minus x derivative 1 minus sine 2x by 4. Again, one more integration. This is between 0 to pi. So 1 by pi. This is minus pi by 2 cos 2 pi plus 1. Cos 2 pi plus 1. And here plus sine 2 pi 0. This is upper limit minus lower limit 0, 0. So what is this value? Pi gets cancelled, minus 1 by 2. Pi gets cancelled, minus 1 by 2. Therefore, what is b1 value? Minus 1 by 2. Finally, therefore, half range sine series is f of x equal to, separate b1. What is actually sigma bn sine nx, equation 1. N equal to 1 to infinity. So let me separate b1 sine x plus summation n equal to 2 to infinity bn sine nx. So what is this value? X into cosine x expansion is minus 1 by 2 sine x plus summation n equal to 2 to infinity. What is bn? Minus 1 whole power n. 2 into minus 1 whole power n by n square minus 1 sine nx. This is the answer. Bn expression correct? 2n. Yeah, 2n into minus 1. This is simple problem. Half range sine series. Let me do same question. Find same problem, half range cosine series. Half range cosine series of f of x equal to x into cos x in 0 to pi. This is assignment. Try this. Okay. Yeah. Any doubts? Is concept is clear, everyone?
Yes, sir.
Yes, sir.
Sir.
Yeah. Okay. If concept is clear, you can do problems.
Sir, for internals, do we have to come to college?
Till now, it is not decided.